Today, we're going on a time travel tour through every single Wi-Fi generation, from the first crackly connection to the mind-bending speeds of the future, all in the next few minutes. Let's rewind to 1997. The internet was mostly dial-up, and if you wanted a real connection, you used an Ethernet cable. Then came Wi-Fi 1, officially called 802.11. Think of this as the dial-up era of wireless. It ran on the 2.4 gigahertz frequency and had a max speed of just 1 to 2 megabits per second. It was revolutionary because it cut the cable, but it was painfully slow, incredibly unstable, and had poor security. You'd only find this in labs or universities for early experiments. It was proof the idea could work, but not much more. Just 2 years later, in 1999, things got serious with Wi-Fi 2, or 802.11b. This is where Wi-Fi went mainstream. It stuck with the 2.4 gigahertz band, but boosted speeds to 11 megabits per second. Why did this one take off? The hardware got cheap, and it had good range. This was the birth of the home Wi-Fi router. Of course, the downside was that everyone, including microwaves and cordless phones, was now crowding the 2.4 gigahertz band. But the impact was huge. Wireless internet became a consumer product. Now here's a twist. Also in 1999, a different standard was released, Wi-Fi 3, or 802.11a. This one was technically superior. It jumped to the cleaner 5 gigahertz frequency and hit 54 megabits per second. So why haven't you heard of it? It had shorter range and the hardware was really expensive. So while 802.11b went into homes, 802.11a found its place in businesses and offices. It was the faster, premium road that most people couldn't afford to take. The industry needed a winner, and in 2003, it arrived. Wi-Fi 4, or 802.11g. This was the best of both worlds generation. It brought the 54 megabits per second speed of Wi-Fi 3 to the 2.4 gigahertz range of Wi-Fi 2. It was fast, had great coverage, and was backward compatible with all those 802.11b devices people already owned. This combination made 802.11g the default, reliable home Wi-Fi standard for years. It made Wi-Fi both fast and affordable. Then, in 2009, we got the game changer, Wi-Fi 5, or 802.11n. This was the modern Wi-Fi revolution. For the first time, routers could use both the 2.4 gigahertz and 5 gigahertz bands simultaneously. Speeds skyrocketed to up to 600 megabits per second. The secret sauce was two big innovations: MIMO, which used multiple antennas to send data at once, and channel bonding. This meant stable HD streaming, online gaming became truly practical, and multiple devices in a home could work smoothly. This is the generation where Wi-Fi stopped being a compromise. As our homes filled with smartphones, tablets, and smart TVs, Wi-Fi needed another upgrade. We moved to Wi-Fi 6. Now here's where naming gets funky. Technically, this is 802.11ac, released in 2013. The Wi-Fi 6 name came later to make things simpler for consumers. It operated on the 5 gigahertz band and pushed speeds toward a theoretical 3.5 gigabits per second. Its key upgrades were beamforming, where the router focuses signal directly at your device, and MU-MIMO, allowing it to talk to multiple devices at once. This generation was built for a world with 4K streams, gaming, and a dozen smart home devices all online simultaneously. But with everyone on the 5G HZ highway, it started to get crowded again. The solution? Build a new highway. That's Wi-Fi 6E. The E is for extended. Technically part of the 802.11ax standard from 2020, it added a brand new frequency, the 6 gigahertz band. The speed is similar to Wi-Fi 6, but the 6 gigahertz band is almost empty. That means way less interference, lower latency, and a cleaner signal. It's perfect for virtual reality, glitch-free video calls, and dense environments like apartments. Think of it as the same powerful engine from Wi-Fi 6, but now driving on a wide-open, empty road. And that brings us to the horizon, Wi-Fi 7, or 802.11b, starting to roll out now in 2024. This is the future. We're talking theoretical speeds up to a staggering 46 gigabits per second. It introduces technologies like 320 megahertz wide channels and multi-link operation, or MLO, where a device can use multiple bands at the exact same time for ultra-low latency and rock-solid stability. Wi-Fi 7 is being designed for the most demanding tasks: immersive AR and VR, 8K streaming, cloud gaming, and the infrastructure for smart cities. Its goal is simple: to feel as reliable and fast as a wired Ethernet cable, but completely wireless. So, from a wobbly 2 megabits to a blistering 46 gigabits in just over 25 years. Each generation solved the problems of the last and paved the way for the applications we take for granted today. It's a story of constant, quiet innovation happening right in our living rooms. Thanks for watching, and I will see you in the next video.